Hey everyone, welcome to Data Umbrella's webinar. I'm going to do a brief introduction and then I'm going to hand over the microphone and the camera to Julia. And if you have any questions along the way, please put them in the chat and we will get them answered. And we do request that you please keep the questions on topic. And today's presentation is on Holoviz, so those are good questions to ask on Holoviz. This is being recorded and the recording will be available within 24 hours. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. A little bit about me, I'm a statistician and data scientist, and you can find me at Reshama S on Twitter, LinkedIn, and GitHub. We have a code of conduct, and we thank you for helping make this a welcoming, friendly community for all, and our code of conduct applies to the chat as well. There are various ways that you can support Data Umbrella. The first and foremost is to contribute to making it a welcoming community. You can also join our Discord and ask and answer any questions there. You can share events and jobs and other things as well. You can also support us by donating to our nonprofit. We are on Open Collective as Data Umbrella. And if you work for a company that uses Benevity, Benevity is a company matched platform. And so whatever you donate, your company will match it. And so you can also find us there on Benevity. Another thing that you could do is subscribe to the Data Umbrella YouTube channel. And it is /Data Umbrella is our URL on YouTube. All of our webinars are on YouTube, and it's a really great library. We have a bunch of playlists, and one of the playlists that's really popular is, for instance, career advice. And some of the playlists are just data visualization, data science for beginners, and a number of playlists related to open source and contributing. We also have a monthly newsletter on Substack, and our URL is dataumbrella.substack.com, and we aim for the first of the month to let you know what happened previously and what's coming up. Our website has a bunch of resources, for instance, guides to using inclusive language, which we practice here during our webinars, and a lot of extra resources on accessibility and responsibility as an example. We are on all social media platforms as Data Umbrella. Twitter and LinkedIn is where we share a lot of resources. Meetup is the place to join to find out about upcoming events. And I've mentioned YouTube and newsletter. We also have a really nice blog with a lot of content coming up. This webinar platform has live captioning. So at the very top, you can see CC, and that's for closed captioning. If you click on that, you can see a live transcript. This presentation by Julia is the last in our this month's series to celebrate Women's History Month, and it's Intro to Holoviz. If you missed any of our other presentations, they are on YouTube. We have a few upcoming events. On April 5th, we're doing Editing Wikipedia because someone has to. On April 26th, we have Intro to GraphQL. And on May 10th, we have an Intro to PyTorch webinar coming up, and you can sign up for those on our Meetup page. Although I think the PyTorch isn't up yet, but mark your calendars. Today's talk is Introduction to Holoviz with Julia Signell. Julia has worked in the scientific Python ecosystem as an environmental researcher and open source contributor, and on both the front end and back end data science platform product teams. She is passionate about finding creative ways to enhance understanding of the physical world. In her current role as head of open source at Saturn Cloud, she helps to maintain DAST and contribute to product management and engineering. Before joining Saturn, she worked on the Holoviz team at Anaconda and as a hydrometeorology researcher at Princeton University. And you can find Julia on Twitter at jsignell as well as on GitHub. And I will share the link to the slides in the chat as soon as I'm completed. And with that, I'm going to hand over the camera and the screen over to Julia.
Cool, thank you. All right, let me grab that screen. All right, thanks for having me. So the material for for this talk can all be found at on this GitHub repo, which Reshama is dropping in the chat. So you should be able to run these notebooks on Binder or locally on your own machine by following the instructions on this README. Yeah, so currently I work mostly on Dask, but before joining Saturn Cloud, I worked at Anaconda and I was working a lot on Holoviz. So that's what this talk will be about. So I had to brush up on my skills to write this. So hopefully it makes sense. So the goal of this talk is to let you use Holoviz tools to visualize tabular and array data in Python. And really the emphasis is on being able to see what's going on in your data as quickly as possible so that you can explore it and understand it. We're going to be doing a lot of walking through notebooks. So if you're familiar with notebooks, that's great. If not, it should still make sense. And also if you're familiar with pandas and NumPy, that's a good starting point. So there's instructions on the README about how to run the notebooks. And with that, I will get started. So I'm going to start by framing a little bit about what we want out of visualizations. So we want to explore, we want to see patterns in the data, we want to identify bad data or suspicious data. We want to develop intuition about what things might mean. And then we also want to be able to show our data to other people and tell a story. So with that in mind as our objectives, what do we want out of visualization tools? We want interactivity, so we can zoom into areas of interest. We want to be able to re-render the plots based on user actions. Maybe we want to be able to draw on plots. We want reproducibility, so we want to be able to look at the same data again for a different year or a different state, or look at different data using the same analysis. And we want shareability, so we want to be able to deploy a dashboard or share a notebook with an environment specification so that other people can run it themselves. And so you can tell the story that you're trying to tell. So to get all of those, to attain all those goals, we're going to be talking about Holoviz. So specifically in this talk, we're going to be focusing on HvPlot, which is the kind of the it's a gateway into Holoviz, and it allows you to quickly inspect data and see what's going on with it. So how it works is there's all these data libraries, like pandas is probably the most prominent one, but then there's GeoPandas, and there's different types of data frames that are lazy or on GPUs, and then there's X-array, which is n-dimensional labeled data. So there's all these different ways of having your data stored in Python. And then there's this .plot API. So if you've used pandas and matplotlib, you've probably experienced calling .plot on a data frame. So it's the same API, a little augmented, and you can call .hvplot. And what that does is it goes through this intermediate layer of creating a HoloViews object. We aren't going to talk about that much, but then it comes back out the other side as a bokeh plot. And bokeh plots are, one, very beautiful, and then also they have all this interactivity because they have a really strong JavaScript layer. So bokeh has a JavaScript bindings. It uses JavaScript to draw on the screen, and then it has Python bindings so that you can just write Python code and get this this interactive visual output. And then there's this optional step of going through Datashader, which aggregates the data to the pixel level and allows you to quickly drive meaning from really large data sets. So that's kind of the overview of how this world works. So now that we've introduced that, we can talk about the data set. So this notebook, we'll be looking at bird data. So this is data on the migration patterns of various bird species. in the course of a typical year. It's collected by citizen scientists and then cleaned and aggregated by scientists. And so there's just one location for every day of the year for each species, and that's the center of that bird species. So like the center of mass of those birds. And these are some references for the data. So the way the data are structured is there's a directory that has all of the CSVs of where each CSV represents a different species and contains the locations, the lat lon, for every day of the year for that species. So to get a sense of the data, we can load just one file using pandas. You can see it's a day in the lat lon. And then we can read in all the files, add species as a column, and concatenate them into one data frame. This is using pandas. It's a little involved. So for the rest of this talk, instead of using this pandas approach, we're going to do the equivalent, but we're going to use intake. Intake is a simple wrapper, really, that gives you access, that allows you to access data in a more simple pattern, and also it allows you to abstract off the complexity of like loading data. So in this case, we're using intake.opencsv with the species here as a little pattern, so that gets added as a column, and we can read it in. So we have the same data set here collected, concatenated across all the birds. And we can look at just one species column. It's a little, I zoomed in too far. But you can see that there's 117 different types of birds in this data set. And they all pretty much have every day filled out. So they all have the same frequency. So that's the overview of the data and a little bit of a framing of the tools. So now I'm going to go out of the slide view and into notebook land. I'm going to zoom in a bunch. Maybe one less. Okay. So now we'll start talking about the visualization libraries. We're going to start with HvPlot. So we'll load in our data. And the first thing you want to do when you're using HvPlot is you need to import hvplot.pandas. What that does is it adds a method on the data frame object that is this .hvplot. And that's what we'll use to create plots. So our first plot that we're going to make is all of the birds, all of the days, lon versus lat. So these are all of the birds. Each bird is represented as a point on every day. So already we have some information on this plot that was very straightforward to put together. We have the interactivity of being able to hover and see the lat and lon. We can also zoom in to inspect different areas. And we can see these like trajectories that different birds make. But we're not getting the most out of this data that we can. So it's kind of hard to see all the dots. So the next step we can do is we can apply Datashader. So all we've done is added this Datashade equals true option. And we see now that we have the data, all the birds aggregated to essentially the pixel level. So the darker areas here are where there's more birds, and the lighter areas are where there's fewer birds. So that's a quick way to aggregate data that is that's overlapping, overplotted. You can read a whole much more about Datashader, but we're actually not going to get into it that much in this talk. So the next step is how can we use color more effectively? Because right now we're plotting all of the days at once, but we can also, instead of doing that, we could color by day so that we can sort of get a sense of where the birds are at different times of the year. So in this case, since days of the year is a circular feature, I've plotted it on a circular color map. So the winter is blue and the summer is yellow. So you can see that. You can sort of start to see the pattern of the birds being up north in the summer, or at least far from the equator in the summer and then closer in the winter. And the last part that we can do without, just by looking at a two-dimensional plot, is we can tell a little bit about which species is which. So in this case, I'm adding species as a hover column. And so now we can hover over this and we can see the more information about these particular birds. And we can zoom in. And you can see that, like, the trajectories of these of this bird over here, for instance, and figure out what exactly that bird is. This is rendering kind of slow, probably because I'm sharing my screen. But you can hover and see the information about these birds. I'm actually going to cut my video. Okay. So now that we can effectively see our whole data set on one plot, and we can use our interactive tools to explore. So that's pretty good. But if we're interested in looking more closely at a particular species, we can use grouping to look at that. So here we're grouping by, we've added this group by equals species. And we have the same plot as we had before, where a day is represented as a color map. And on this, and we can choose different species and look at their particular trajectories across the year. And that's a really interesting different way to explore the data. And that is one of the big features of HvPlot and the whole Holoviz world, is this ability to split plots up and use widgets to control the behavior of the plot. So we can inspect just one bird the same way that you would use a dictionary, where we can just select one particular species and get the plot for just that one. And the last thing we're going to explore here is combining plots. So we can combine different plots using this plus operator, and that will put them side by side. So here we are plotting our birds as dots, and then we're also plotting day versus latitude with a histogram on the side to see how long they spend at different latitudes. And these plots are linked. So you can choose different birds and they both change. I'll do that a couple times in case the lag makes it unclear. And then you can also, they're also linked in terms of zoom. So you can like zoom into particular sections and see just that section of both plots. All right, so next we're going to talk about how you can use Holoviz or HvPlot to look at not just tabular data like the bird species, but also array data. So I'm still going to load my birds though. And in this, we're going to be adding in a data set, which is the air temperature across the whole globe on average across day of year. So it's going to be one. So I'm going to load it using Xarray. So Xarray is a library for interacting with n-dimensional data that has labels. So in this case, my labels are time, latitude, and longitude. And then I'm going to have air temperature for all those. So I'm going to load it from this NOAA site. And that's all fine. And then I'm going to set the time to be in terms of like integer day of the year, the same as my birds is. So here is my day of the year. And I am also, while I'm messing with this data set, I'm going to select, it had a bunch of different levels of air temperature at different pressure levels. For this case, we just want one pressure level, which is close to the surface of the Earth. And then I'm going to save that off into a data file for later. All right, enough of that data wrangling. Now let's look at our plot. So this is the mean across all the days plotted just lawn versus lat. So you can see the edges of the continents here. And you can see that we have hover where we show the temperature for all these different locations. And same as before, you can zoom into particular areas and inspect those more. Since the bird plot and the air plot are both HoloViews objects, we can combine them on the same axis. So in this case, we're going to use this asterisk operator to overlay them. So that's like one of the big takeaways I think from this talk will be the plus lets you put them side by side, and the star lets you overlay them. So here we have overlaid birds on air temperature, except we haven't because they have different, turns out they have different conventions for longitude, these data sets. So really what we want is we want to put them in a geographic context. So instead of just overlaying them, we're going to add this geo equals true. And that just means like it is geographic data. And behind the scenes, that means it's going to use GeoViews rather than HoloViews, which is transparent and doesn't really impact what you need to know about this. I'm also adding a coastline feature, so that'll draw some little coastlines. So I'm rendering that. And now we can see our air temperature with coastlines drawn on and all our birds zooming around the Americas. So that's, so next, we're going to leave that there for now. I probably should have mentioned this at the beginning, but we're building up these visualizations, and then at the end, we're going to make a dashboard that captures all this information in it. So the next thing we're going to do is we're going to explore the data a little more using interactive. So I'm going to start by loading my data sets in. And instead of using HvPlot in this notebook, we're going to use .interactive. And that allows us to inspect our data and select it across various dimensions, not just as axes or colors in a plot, but also as just purely by slicing it up and creating tables and stuff. So to do that, we're going to import panel, which is a library that's also in the Holoviz world, probably actually in this visualization of our tools, probably it should like go around everything, because panel really is what allows you to put everything together into dashboards. So we're importing panel, and then we're also going to import hvplot.pandas and hvplot.xarray. So to start with interactive, we're going to make some widgets. There's a whole bunch of widgets that you can see in this panel widget gallery. So if you ever are at a loss for widgets, they are there. But for now, we're going to start with the int slider. So it's just a slider that allows you to select different integers. And we're going to use that for day of the year. So here's my little slider. You can slide it along. And then at any point, that slider has a value. So if you slide it, you can always find the value of that. Now that we have that widget, we can create an interactive view of our data. So we're going to take our air temperature, and we're going to add .interactive to it. And then we're going to select the day that has the value of that slider. So here we have that slider, and then we can slide it along and see our data values change. So these are the air temperatures. It's kind of hard to read this array, but it's just an array of temperatures, basically. And we can use that interactive data as a basis for other visuals. So we can select the day and using the day slider, and then we can plot it using HvPlot with our geo as true and our coastline. And we should have a plot that looks very similar to what we were messing around with in the last notebook. Right. So instead of looking at the mean temperature now, we're looking at the temperature across various days of the year. And we can put the array view of the data and the HvPlot, like the plot view of the data, together by using a panel row. So we're just saying we want a row that has the table and the plot. This is looking actually, I made it a little too big once I zoomed in. But you can see that if you drag it around, you get updates to the array and you get updates to the plot. So now we'll slice up the bird data a little bit. So first we'll make a species selector. So we'll make a select widget, which we just picked out from the reference gallery, with a name. And the options will be all of the categories of species. And I just sorted them so they'd be alphabetical. So we've got our selector. We can choose any of the birds. And now we'll make an interactive data frame out of our bird data. And we will select all of the birds. We're trying to look at where the birds are on any particular day. So this is, find the bird that is the same as the bird that we selected. And this next part is where the day is the date value. And then we'll get the Latin lon. So as we select different options, the lon will update. And now the real cool thing that you can do is you can use that Latin lon as the basis for a table to figure out who is near that bird. So in this case, I'm saying for this particular day, given that this bird is at this Latin lon, who is within a 10-degree bounding box of that bird. There's better ways to calculate distances for what is near things on Earth, but I didn't really get into that here. So it's just a 5-degree bounding box. And you can see that we get, as we slide around different days, this will update. And if we choose a different bird, we'll have we can see who is near it on that particular day. There's some questions in the chat, so I'll just address them now. So there's a question about, does the group by feature work for multiple categories? The answer is yes. And we'll see some of that in the next notebook. And then, can the plots be downloaded as HTML? Also, yes, but some of the interactivity might not work if it's backed by Python. So if the interactivity is backed by JavaScript, then it will work, which is, all the zooming in and zooming out, that will all work. But some of the widgets might not work inherently because they need a Python engine running to back them. Okay. So there's a lot more about interactive on the Holoviz tutorial and the Holoviz docs, so you can explore that more. But next up, we're going to be making the dashboard using panel. All right, so we're going to start by loading our data in again. And I'm going to slice the air temperature down to just America. And then so far with panel, all we've done is used the widgets, and we've created some little rows just to see things side by side. But in this notebook, we're going to be creating a whole dashboard. And panel dashboards can really take any type of inputs. They can take HoloViews objects, so anything that HvPlot spits out, or text. You can write Markdown. You can embed HTML. You can really do, you can put almost anything in a panel object. So here we're importing panel, and we're importing this this table making extension, and then HvPlot. So we're going to make some widgets. We're going to make the date slider from before, the species selector, and now we're going to make our different components of our dashboard. So this first part is a map of all the birds with the temperature underneath. So first we have the air temperature, and then we're going to layer on top of that using the asterisks all of the birds. They're going to be grouped by day, so all of the species will show up there. And then here's actually a multiple group by. So here we're going to group by day and species for the next plot. There's smarter ways to do what I'm trying to do in this plot, but this one was really fast to write up. So it's just 3 layers of plots on top of each other. This one has all the birds for one particular day, and this one will have one bird for one day. So we can highlight a particular bird. Let me run that cell. And then another part of the dashboard will be an overview of the year for a particular bird. So we'll look at longitude versus latitude, and we'll look at how much time the birds spend for the entire year. And then we'll look at how much time the birds spend at any particular latitude. So that's a histogram. This I will not get into very much, but I encourage you. I was trying to make a title where the species would update when the widget updates. So I ended up going down this route of linking objects together using panel. There's a whole bunch of documentation about it, and there's a lot of different ways that you can do it to have it be just JavaScript or Python backed. But for the purpose of this conversation, just know that when species widget updates, my title will change. And then the last part is adding in an interactive table that shows the birds that are nearby the bird that I've selected. So this is from the 3rd notebook. All right, and then there's just some text that I'm going to put on my dashboard. Pretty much the same text from the overview, explaining what the data is and the references. And then the last step is putting all these components together into a dashboard using a template. So here I'm using this template that I picked from the panel docs. It has a title, it has a sidebar, and then it has a main section. So in the sidebar, we have the different text basically and the widgets. And there's just a list of them. And then in the main section, we have rows and columns to compose this layout that we of all our plots and visuals. So once you've created that layout, you can pick some colors, and then you can use template.show to show this. So this will open a new tab where I'm going to zoom out a little so it fits properly. So this is a new tab that has that's running from my notebook. And here you can see all of the birds are in white, and then the bird that we've selected is in black. We can change to a different bird. I noticed that sandpipers have really crazy patterns. And then you can slide the day of the year around and watch the bird move on both this plot and this table of nearby birds also changes when you update things. And then here we have a tab component that just does an overview of the year for this particular bird. You can still interact with these plots. Zoom in. I'm getting my clicks messed up. You can zoom in. And the last part I wanted to show is that right now I'm running this just directly from the notebook. You can also, I'm going to comment that out now. If you want to run this not from the notebook, you can run it as a separate process by setting template.servable. So I'm going to save that. And then I'm going to go to my terminal. And here, there's a fresh terminal. And I'm going to do panel serve that notebook. And now I'm running in a different process. And it will appear here. So I'm clicked that link and I can see it's coming up now. But it'll be the same dashboard, but running in a separate process. So it doesn't have to be tied to Jupyter, but it's still running from that notebook. So I'm going to go back to this overview. So what we've done is we've explored the pandas data, X-ray data. We plotted it using HvPlot, which generates HoloViews objects that then are outputted as rendered bokeh objects. Sometimes we have Datashader in the mix. Sometimes we have GeoViews in the mix, actually. And then this whole thing can be popped into a panel object to make a dashboard. And that's the end. And I guess I should do some references. So there's all of this information about all these things can be found on the holoviz.org. So there's separate sites for panel and HvPlot. There's a large tutorial, and you can always use this as a jumping off point. So with that, I can go to questions if there are any.
Hey, Julia, thank you so much. So there is a question in the chat, which is, can you embed the panel in a page to share with someone or upload it to a Google Doc folder or something like that?
Yeah, so you can, this is similar to the, can you download as HTML? If the panel interactivity is JavaScript based, then you can download to HTML, iframe it in somewhere, embed it wherever. If it's backed by Python processes, so if it's selecting from the data set or on the fly, or if it's aggregating in some way on the fly, then that interactivity won't work unless there's a running Python process.
And another question from me is, you can also, I don't know, you can also use Holoviz to put plotly plots in a dashboard. Is that so?
Yep. Yeah, you can put any type of plots in a panel dashboard. You can put matplotlib, you can put plotly, you can put Altair.
So back to the other question, the person is saying you just export it with Holoviz. Is that it?
Yeah, there's some, I can't recall the API. I think it's .save or something. It's just a, yeah, you can look at the panel docs for exporting, or the bokeh docs for exporting, depending on whether you have a panel object or a HoloViews object rendered in bokeh.
Oh, sorry, I was on mute. Somebody had a question when you were showing the map, which is, can you select the side for the map to the left?
Can you select the size of the map? Yeah, you can always control the size of the plots using .width or .height, or for geo, maybe .frame width. So here I have it set to 500. which looks good at this zoom in, but doesn't look as good at when I zoomed in more.
Okay, if anybody else has any other questions, feel free to post in the chat. Meanwhile, I'll just ask Julia questions. We sort of discussed this before the webinar officially began, was how did you get started in using Holoviz?
Yeah, so I started out as an environmental engineering researcher, and I was doing a lot of plotting. I was plotting lightning strikes over time, so I was making a lot of plots that had more dimensionality that can be shown. So, like for instance, they would have lat-long lightning strikes, and then time would be like another dimension that I wanted to capture. And at that time, I was just using matplotlib, but I was using Xarray, and I think that's how I became aware of Holoviz. And I saw a talk about Datashader, which really really blew my mind, because Datashader allows you to aggregate to the pixel level rather than plotting all of the data, even if you can't see it. So it just makes a lot of sense. And that's, I think, how I first got introduced to Holoviz. And then I got an opportunity to work on it, which was very cool.
That's great. Do you also want to just sort of share how you, we were talking about this before, is how, why you are using this example to show Holoviz?
I just think the birds are cool, mostly. I really like geo data. I think it's interesting to try and represent. It's often inherently more than two-dimensional, because there's always lat-long time, and then there's something else, like whatever you're interested in. So it's interesting data, and then it also just, people can really understand it, even if it's not their area of expertise, because everyone knows about temperature in birds.
Great. I guess the other thing is just to say also is because you studied environmental, I forgot your major, but that's one of the reasons that you used this specific example, right?
Yeah. Yeah.
And just to read something that James Bednar posted in the chat, which is, group by is done in Python, but you can embed the output of it, which means to pre-compute the plots for each group separately, which lets it be exported to HTML in a way that's still live. And then parentheses, though the web pages can get pretty big when there are many groups. And see the embedding section in the panel docs.
Yeah, so that's a way to get around the needing Python to execute thing. You can pre-compute all the plots, and then then you can just rely on pure JavaScript to select between the plots, essentially.
Great. And I have one last question, which is, I've been exploring a bunch of the tools to create dashboards, particularly Python and JavaScript, because I really like the interactivity of it. And do you see, being so closely involved in this, do you see what's on the horizon for what's coming in these areas?
Well, I think we're always, Python, the visualization in Python is, for whatever reason, like nothing has really won. No particular tool has really won the like mind share or whatever, won the space. So I think a lot of times the Python tools are chasing, in the case of dashboards, they're chasing R. So they're chasing R Shiny in particular. So really, if you want to know what's coming for Python dashboards, I think you should probably just look at R Shiny and what the capability is there. And I think they will all be trying to get that.
I love that. It's the Python visualization dashboard wars.
Yeah, it's not wars. It's just everyone, there's a clear thing that works well in the R community. So I think everyone has a pretty clear sense of that being a target. And there's other areas in Python where one tool has really won is really the most popular one, like pandas or something, that's not necessarily the case in R. So like in different areas, there might be different, just in terms of history, a different different like conversions on a particular tool.
I should probably say maybe like the race or the path aligned instead of yours. And do you personally use R Shiny? Have you used it?
No, not really. I don't do much in R, but I interact with R people, and I know it seems good.
Great. With that, I don't see any more questions in the chat, and so thank you so much for presenting. I had been looking for a while for someone to present on Holoviz, and I'm so happy that you came back with a yes response. So thank you so much.
Yeah, I'm glad it worked out. Thanks for having me.